got a couple of gears here, cylinder falling. After 2 meters, basically we want to find the speed of that cylinder. So again, position at a specific, or velocity at a specific position, we're going to use energy. The only thing acting here is, sorry. The only thing acting here is, so we're going to conservation of energy on this guy. Okay, and we'll go with that. So what we'll do here, since energy is conserved, we'll go ahead and write, whoops, excuse me. Oh, God. Sometimes I swear. We will use KE1 plus PE1 equals KE2 plus PE2. And here's what we're going to do. We're going to starts from rest. We're going to call that 0. And what we'll do is we'll say the final potential is actually 0. So it's going to end at 0. And really the only thing that's happening here is the cylinder is falling. Okay? So that means initially it's got a potential energy of the distance that it falls, which is going to be mg times h. So 50 times 9.8 times h, which is 2 meters, right? KE2. Now I've got 3 things moving. I've got the cylinder, which I'm interested in knowing, so it's going to be 1/2 50 v squared, 1/2 mv squared, and then I've got these 2 gears, right? So we'll start with that would be the 30 kilogram, which has got the drum on it. That's what the cylinder is attached to. So we'll say that's going to be 1/2, and again, this guy's not translating, so it's just going to be I omega squared, where I is the mass of 30 times the radius of gyration of 0.15 meters. So that's I, and then omega is again related to the velocity by that 100 meters. So it's going to be v divided by 0.1 squared. So that is the gear C, basically, with the drum on it that the cylinder is attached to. Okay. Now we're going to move on to the other guy, which is going to be, again, doesn't translate, so I omega squared, 1/2 I omega squared, where now this is 10 kilograms, radius of gyration of 0.125 squared, okay? And now I need to know, what the velocity of that guy is, okay? Yeah, the omega and how that relates to the velocity, right? So again, what I know here is that, I'll just come over here, omega b is equal to v divided by 0.1, just like I had before, okay? Now, using the gear ratio, I know that 0.2 omega b has to equal 0.15 omega a. Okay, that means omega a equals 0.2 over 0.15 times v over 0.1. Okay, which comes out to be 13.3 when I do all that. Okay, and I'm going to square that, so it'll be 13.3 v squared. Okay, so big ugly equation. Okay, but it's really only got one unknown in it, and that's v. Okay, so you can go ahead and set PE1 equal to KE2 and solve for v, and you get v equals 3.67 meters per second. So again, remember, the energy is all of the pieces together. So you've got the cylinder and then each of the 2 gears that are rotating, and gravity is the only thing acting on this guy. So that's the only potential energy that we have.